Alright, so today I'm going to quickly help Chad out with one of the issues he's having, but after that we're going to get into a session about raycasting. We'll start by an example of using raycasting to teleport around, basically using a laser pointer from your controller, uh, pushing down the touchpad, and then letting go to teleport to that location. Alright, now Chad, what's going on?
Okay, so I have my right and my left. My monster's coming at me, so I gotta hurry up. So I grab this ball and it kind of throws. This is what's interesting. I grab these two things that work. I can't let go of this one still. My monster got me, but I can let go of this and grab this. Look at it, just does this thing. It's like magically pulled because I can't really drop this one. I can't drop my right hand. If I pull off of it, it goes back to it. So I can't, once I grab something to the right, it doesn't ever go away.
Okay, can you select that gun? Stay in play mode. Select that gun from the hierarchy tab.
Okay.
Just want to see what's going on with it.
All right. Oops. Goodbye, monster. Select the gun or the controller?
The gun.
Okay.
So that's the one that's stuck on you here. Can you focus in on
Well,
that?
any device with my right hand, anything I grab with my right hand sticks.
I see. So and then you said your right hand. So let's select your controller right. Let's see what's the difference there. So your left hand, you said no problem, everything's working fine.
Right.
Okay, let's select your left hand. And sorry, go back to the right. The scripts seem to be different, Chad.
Yeah. Well, one's right and one's left, but yeah.
I mean, like, you see the hand right script is missing quite a few variables.
Right. So should I look at that script, pull it up?
Yeah, I think it's safest to just basically copy paste the left controller script onto the right, except simply change the name as well as the input statements.
Okay. So copy the left. Where are my scripts? And left. So just make a copy of that.
No, just open it up. We'll actually copy paste from within
Okay.
the script itself.
So all of that.
Yeah, pretty much. Left hand, copy it over to your right hand. Just making sure to remember the fact that it's right hand is the secondary.
And just delete all this.
Yeah, just paste it over, and then we're going to go up to the top where it says public class. And you change where it says public class hand left to hand right.
And anything else?
Now, in your if statements, when you're checking, OVR input dot access 1D, change primary to secondary.
Can I do a search and change, or have to go to do each one manually?
You can do a search to change. You do the control F and replace and stuff.
Oops.
I think there's really only one left, so might as well.
Yeah.
Okay, and so one thing I want you to see is, you notice how in your if statements you have if secondary index trigger on the shoot part of it. that was your copy pasted from the left hand. So save this right hand. I'm going to go back to the left and we're going to update some lines there as well. So your left hand, pretty much correct, except when you're looking at the shoot function. So let's scroll on down to the update, or scroll on up a little bit. Okay, so right there, here it says line 62. It says secondary index trigger. So remember that's referring to the right hand, but the script is attached to your left.
So change that to primary.
Exactly. Yeah. And same with line 71.
Oh, that was another problem I was having, so that will fix that. I was having to use my left or my right hand to pull the trigger, even though I have an object on my right. So that would probably fix that.
Yeah, that would do it.
Cool. Anything
Although
else?
that is kind of a cool effect too.
If you want to call it that. Thank you for saying that. It wasn't very cool. Okay, so what I do? Try it out?
Yeah, go for it.
Oh, I'll do that. Okay. Okay, so right hand, left hand. Cool. Oh, that's interesting. Okay.
What happened?
It instead of like firing the trigger, it shot it when I pulled the trigger for the gun. It shot the whole gun out of him instead of the trigger.
Okay. Oh, right. We got to make sure we have those references. So select the right hand in your in the hierarchy tab. Controller right, I should say. So in the script, you'll notice that it has prefab paintball and shoot location and shoot force. Those are not referenced, and the shoot force is 0, so those are the values you need to adjust.
Oh, should I just drag the
Spot
under
gun
spot over to paintball?
over to the shoot location. And then you have a prefab paintball in your folder somewhere. Yeah, it looks like the sphere.
Yeah. Could I use any spherical shape, or does that have to be?
It just needs a rigid body, if you remember. That sphere, I think we went through and defined it to have a particular rigid body and stuff. Go ahead, hit play.
Okay. Yeah, that works. Dropped it. And
The scary looking demon you found, Chad.
I made him in medium.
No way.
Yeah.
Wow. Impressed, man. Thoroughly impressed.
Cool. It works. Awesome. Thank you.
No worries. Okay, so let's get into raycasting.
I'll let you take over. There you go.
Alright, and share my screen. By the way, how's my mic quality?
Excellent.
Awesome, I got a new headset.
Oh, good.
Wireless.
Ooh. Freedom.
Freedom indeed. The other one has the longest wire and I keep tangling on it. Alright, anyways. Let me get out of this folder here. So what we're going to do is essentially create a visual representation of a laser and basically use the physics engine in Unity to cast a laser between your controller going forward, and whatever it hits will be the endpoint. Now, by default, Unity doesn't give us a visual representation of that. It's an invisible line. We're going to create a laser to represent that line, as well as actually implementing it. Let me just double check if I'm not missing anything. So, okay. So when it comes to mobile VR, this is where we really get into some use in uh, the raycasting. Okay, so originally we've been using this whole 6DoF system where you're using a controller like the Vive or the Oculus Rift, and you can move your hands into an object, squeeze the hand trigger, squeeze the grip button, and move it around. Now you don't really have the ability to do that with something like the Gear VR controller or Oculus Go controller. You can simulate something kind of like it, but not remotely close to it. But the biggest thing that they do have in mobile VR is the ability to use your controller like a laser pointer. It tracks the orientation. Now, with 6DoF systems like Oculus Rift and Vive, you have that orientation as well. So what we'll do is we will basically use the laser onto both of our controllers. Now, if you're using the cardboard, this would be what you would apply to the headset itself. However, you wouldn't want an actual laser to appear. You would just do the raycasting. All right. First method of raycasting we'll use is to teleport around. Okay. So let's create a new script. Or actually, before we do that, let's prep our laser. So, got a folder called laser. I'm going to create a couple objects here. So number one, I'm just going to create a cube. Normal cube, and I'm going to scale it down a lot. So X and Y are going to represent its thickness. So let's say if I was to go with 0.05, 0.05. So that gives me a rather thick laser. You can get even thinner than that if you'd like, but that's the general idea. Now with that said, we're actually also going to take that Z and just set that to 0. Now let's focus on this guy here. So right now, it has no depth. It's infinitely thin. The idea is that when we start using the laser and we point to a place, then it becomes longer to represent our laser based on the distance. It goes from 0 to a long laser. Okay. So now with that explained, we're going to create a material for this laser, and we're going to make this material unlit so that it prevents it from casting shadows or receiving shadows. So for example, if you were in the middle of a dark cave and you pointed this laser, the laser itself would not appear to be dark. It would still remain the same brightness. So we're going to go ahead and create a new material. I'm going to call this one laser matte. So I'm just going to add AN just so that I know that this is for our AN class. So now with this new material that I've created, I'm going to go over to the inspector while I have it selected, and right next to shader it says standard. I'll click on standard and change that to unlit color. Once you've done that, you can just change the main color to whatever you'd like. So let's get pencils up and we're going to do this together. So we're going to create a 3D cube. Once we have that cube created, we're going to go over to the scale. We're going to set that to 0.05 in the X, 0.05 in the Y, and just straight 0 in the Z. Let's focus in on that. So it's rather small, infinitely small in the depth. And you know what? I'll make the X and Y even smaller, so 0.005. 0.005. A very thin laser. Okay. Now with your laser size, you can create the material. Now, one thing before I do forget, this laser has a box collider on it. We don't want it to have that because when we start creating our laser, the box collider part of it is actually going to start pushing things around. So we're just going to right click on box collider and remove it, or click on that little gear icon at the top right of the component and remove component. For whatever reason, when I move too close to the right, my little pointer focus circle glitches away. Anyways, so this cube is just meant to be a visual representation of our laser. So 0.005 in the X and Y and 0 in the Z. Now with that done, we're going to go into our projects tab and create a new material. So I'm going to right click, go up to create material, and this is going to be our laser material. So I'm just going to type laser matte. I'm just personally going to add AN for my benefit to help keep track of which material belongs to which class, but you can just say laser matte. Now with that material created, I'm going to go into the inspector while having it selected. Up there where it says shader standard at the top right, I'm going to click on where it says standard. A drop down will appear, from which I will select unlit, and then unlit will provide another drop down called color. That's the one you want to select. Now once you have that set up, you're just going to see a main color option appear with a nice white rectangle to the side. You're going to click on that white rectangle and it's going to bring you up a color palette from which you can change the color of your laser. You can determine what it's going to be. So let's say we go with red. After the laser is created, you just click and drag that onto your cube. So that is it. Now you have a unlit infinitely small laser. Now I don't remember if 0.005 is too small, so I'm going to put that up to 0.01 just in case. But there we go. Now once you have this laser set up in this sense, you've removed the box collider, you've set its scale to 0.01x, 0.01y, and 0 in the Z. You've created a laser material that is unlit color, applied it to this cube, which no longer has a box collider after you remove it. You can now create your prefab. Let's name it something that helps us keep track. I'm just going to change its name to laser AN for afternoon, and just click and drag that into your projects tab, and boom, your laser is created. Once that's done, you can delete this laser from the scene. Alright, I'm going to give you a moment to catch up. If you need me to repeat anything, let me know.
Okay. For some reason, it wouldn't let me change the material color in the inspector on the laser mat, it won't. Oh, never mind. I have split screen finally, and it's playing on there.
Nice.
So I have a cube 1 and a laser material on that, but you created two cubes. Let me show you this.
I have 2 sets of laser materials and lasers there just because I've done this once before.
Oh, okay. So I have a cube and a laser material on that cube. And I renamed the cube Laser Ann.
Yeah, you don't have to name with the AN, but it's fair if you do.
Laser, whatever.
Yeah,
So
I should you just
have
click
one
and drag
cube.
it. Once you've done that, just click and drag it into your projects tab so that you have a prefab. And then you can delete it from your scene.
Okay. So basically, I should just have a laser that has a scale of 0.005 on everything but the Z, which is a 0, and a material of a unlit shader. Am I missing something?
No, that looks good. And it's prefab in your projects tab. You're good to go.
Okay. Good then.
Alrighty. So the next thing we're going to do is then create our script. Let's go back into our scripts folder and right click in here and create C# script. Just going to call it teleport in. Alright. So now, if you're using the Vive, go over to your previous hand script. Keep this as a reference. You want to get that initial block of code. It makes this a bit easier to code for yourselves. And boom, just going to do that. Copy and paste that into your new teleport script. We're going to attach this teleport script to your controller, so it'll be good to have.
What about the Rift?
No worries. Don't worry about it.
Okay.
Okay. So, now the first couple of things here. We're going to create a reference to the laser itself. The laser prefab. Oh, let me make that into a game object first. Let's zoom in. That's really small. So yep, after copying and pasting that Vive script, let me just create some more space. First thing we're going to do is create a public game object variable called laser prefab. So now laser prefab is going to be a reference to our file in our projects tab, the one that we just created, and we placed it in our projects tab. Next, we're going to create a public game object that is just the laser itself. So we had similar to how we did the shoot script, where we would call a bullet or a prefab paintball from our projects tab into the scene, and then we would reference that paintball with the pasted paintball variable. Similar sort of idea, laser prefab and then laser. Right, and then we're just going to create a variable called hit point. This is going to be a vector 3. I'm going to call this hit point. Now what hit point is going to refer to is the end point of our laser. Part that when we shoot, it gets information at the end of our raycast. Let me pull up Paint here. I felt like this is a good way to explain it. But essentially, let's represent our controller with these two black circles here. Let's imagine this is our controller. On the right, and our terrain over here somewhere, over here. And this is what the physics engine is doing. When we call the raycast, we need to give it a point of origin. So where are we casting this ray from? And then we need to give it a direction. Where are we? Where are we pointing? And then where do you want to store this information? And what's the maximum distance? So we say the origin is our controller. The direction we're pointing will be forward. So it's going to cast this invisible ray until it hits something. When it hits something, that's going to be the hit point. So once it does this, it's going to say, okay, we've successfully made a raycast. Where do you want to store this information? All this information. Create a variable to store it in, and next time we're pointing, or even on this time, how far can we point? Is this the maximum distance so that if I tried to point up, it wouldn't reach, or it would reach these? So that's the idea. So let's remember that this is kind of how a raycast works. Okay, so these three variables, the first one referring to our laser, second one referring to the instance of our laser in the scene, and hit point's just going to refer to this part here, the part that makes contact with whatever it is that the laser, the raycast hits. Alright, now with that said, do you have this down, Chad?
Yep.
Alrighty.
Good.
With that said, we're gonna create a show laser function. Now this is going to be independent of the start and the update function. I think it'll be easiest if we just do the start function first, actually. So in the start function, we're just going to say instantiate laser prefab. So boom, right out the gate, as soon as the script launches, we're just going to say bring the laser into the scene, instantiate. And before we lose it, make sure we have a reference to it. So we go laser equals instantiate laser prefab. Kind of like we did pasted paintball equals instantiated prefab paintball. We're doing laser instantiate laser prefab. That's it for the start function. Okay, now we're going to create our own function. Go void. Nope. And we're going to call this one show laser. So this function's goal is to create that visual representation of where we are pointing in our world. So with show laser, it needs, based on how we're going to code it, it needs an argument. It needs something to go inside these parentheses. If you remember last time when we were going over the throwing script, we mentioned how you can have a variable that has a data type, so you can do int show laser, or a variable that has an input. So if I did, for example, I did int show laser, so made it a data type as well as giving it an input, so int x, int y. The name show laser may not make sense right now, but the idea would be to then say return x plus y. This function would basically run in the sense that I could say in my start function, for example, I'll say z equals, so int z equals show laser, and then in that function I'll say 2, 2 or 2, 3, doesn't matter. And what this would do is this line of code, I'll just scroll on down a bit. This line of code would call this show laser function. Show laser function has a data type of int, so it can then return an int. It has two arguments in this case, x and y. So when you call the function, you got to make sure you give it two arguments, in this case 2 and 3. function's called, it takes 2 plus 3 and returns that as an integer. So that's why you can say int z equals the return of show laser. Does make more sense as you do it, but how we're going to use it now is to say in our show laser function. So we've created void show laser and then 2 curly brackets just following the 2 parentheses. So we've created our function. We're not giving any particular data type, we're just saying it's void. So inside we're going to create a reference for raycast hit. Just going to call it hit. So instead of an int as our example, this variable type raycast hit stores basically this information here. It gets you this information, where this is, what is this touching, what's the distance from here to here. It has a lot of information, and this data type in Unity is called a raycast hit. Now with that said, what are some things we have to do? First, we're going to need to show the laser. So pencils down, do not write at this time. Laser.setActive true. So that's us turning the laser on. Okay. Next, laser.transform.position. Alright, so we know that we need to adjust this. We need to adjust the rotation. We need to adjust its scale. So once we turn it on, we need to position our laser in the proper spot. We need to make it rotate correctly, and we need it to be the right size. Those are the steps we need to take. So for laser position, basically saying it equals this new function that we are coming across, vector3.lerp. What does vector3.lerp mean? So this lerp function, what it's looking for is it's looking for point A, point B, and then the third argument is the distance in between. So if, for example, we use transform.position as point A, so comma, transform.position, comma, point B will be hit point. Hit point, again, as you know, is referring to this end location. Now, here's the final bit. The third argument is a number, and this number is going to represent the point between these two. So if you were to do, say for example, you wanted the midpoint between position A and B, you would do 0.5f. You know, generally speaking, if you have to write a decimal place, it's a safe bet to just write f after if it's a float. Now, transform.position, hit point, comma, 0.5f. This acts sort of like a percent. You will get the midpoint between the two. If you did, for example, 0.25, this would be the quarter way between point A and B. So 25% of the way from your controller to the endpoint. When I say transform.position, this is referring to your controller, because the script will be attached to your controller. Okay. So now with that said, you would keep this at 0.5. And third, laser.transform.lookAt. And this is for us to orient our laser correctly. So we've positioned our laser into the midpoint. We're then going to make our laser look at the hit point, so the endpoint. It's going to be oriented correctly. And finally, we're going to scale our laser to size. So laser.transform dot local scale, make that equal to a new vector 3. We're going to give it some values here. So that's taking care of position, taking care of rotation, and then for scale, we really only want to change the Z scale. We don't want to change the thickness, so to do that, we're basically just saying laser dot transform dot local scale is going to be the same. Now, to make an exception for Z, we have to go laser dot transform dot local scale dot X. We have to do all three independently, so that one, comma, that, but this time we're using Y. So the same thing, laser dot transform dot local scale dot Y, and then finally the endpoint, the Z scale is going to be hit dot distance. That's the show laser function. I'm going to go through with a little animation for you. So when we press the appropriate button, for the Oculus we'll just use the A button. For the Vive we'll use the touchpad. And this is what's going to happen. So right now, when you cast the ray, you push the A button, you're holding the A button on your controllers, on your Oculus controllers, or you're pushing down the touchpad on your Vive controllers. As soon as you do that, we're going to call the show laser function as long as you are actually hitting something. So what that ends up looking like is, first, there's 4 steps. Step 1, set active. So laser's not in our scene, and then suddenly you set it to active and boom, it's somewhere off in the distance, you don't know where, but it's now set to active. Step 2, again this is done in 1 frame, but step 2 would be then positioning the laser in the midpoint. So we take the position, we say it's equal to vector3.lerp. Lerp looks for position A, position B, and the point in between. And doing 0.5 is 50%, so it's the exact midpoint between point A and B. So that means point A over here, point B over here. We're taking the laser and putting it in the midpoint. So now the laser isn't quite oriented correctly, so what we have to do next is step 3. Have the laser transform dot look at the hit point. So now we say, okay, laser, you need to look at the hit point. So that third line, boom, we're orienting our laser correctly. Now with that said, it's aligned, it's positioned well. The last thing we need to do is change the size of the laser. So we're going laser.transform.local scale is equal to new vector 3. The thickness, so the X and the Y, this way and this way are going to remain the same, but the Z is changed to hit distance. So X scale is X, Y scale is Y, Z scale is now the hit distance, which is the value from here to here. We know the distance, so we're going to scale this guy up to match said distance, and now suddenly you have a visual representation of your raycast.
Oh, that's cool. Okay.
Alright, so let's do that together. Pencils up this time. So in our show laser function, first thing we're doing is typing out laser.setActive. I'm going to set it to true. So this line will allow us to bring in a laser. So boom, our laser is now on. Somewhere in our scene it was off, but now it's on. So laser.setActive, true. Now, laser being on, we want to position it correctly into our scene, sort of in the midway point between our controller and the location our laser hit. So laser.transform.position is equal to vector3 lerp, and again lerp is looking for 3 arguments, point A, point B, and the point in between. So transform dot position, that's just going to be the controller's position. Also go comma, point B is going to be the hit point where our laser strikes. And finally, the point in between we are looking for. So we're looking for the halfway point. So we'll say something like 0.5. F. Again, F just for safety. Oftentimes if it's a float and you're writing out a decimal place, just want to make sure that F is at the end. So now with that line, boom, our laser is positioned in the middle. Let me give you a moment to catch up to that point.
I think I got it. Can you refresh my memory? I know you said this before. Why vector 3 and what is vector 3? Is there vector 1 or 2 and what's the difference and what's that all about?
So a vector 1 is basically just a single value. So typically you don't say vector 1, but vector 2 is a variable that holds 2 variables at once, basically. It's a class. But
Okay.
imagine it like a coordinate system. So a vector 2 holds 2 coordinates, x and y. Vector 3 holds 3 coordinates, x, y, and z. Vector 4 holds 4, and so on.
Okay. Thank you.
You're welcome. Now, with that said, we're adjusting the position. So next what we'll do is orient our laser to face the correct direction before we scale it appropriately. That won't make it look weird. Or you can do either or since it's done in one frame. But let's adjust its rotation. So transform dot look at. This is a nice little function, makes our lives a lot easier. Just tell the laser to look at the hit point. So now, that said, we know the hit point is over here by where X marks the spot. So we're telling the laser, you need to look at that X. The laser will then end up orienting itself to face that X. So that's line 3. And the final line, we're going to scale our laser so that it, truly represents our raycast. So we go laser dot transform dot local scale. So that equals new vector 3. So again, vector 3 just holding 3 values, x, y, and z. And when you're adjusting the transform of a component of an object, it has position, rotation, and scale, all of which have 3 slots, all of which have 3 values, x, y, and z. So when you try to update these, you got to make sure that all 3 are covered by issuing a vector 3. If this one seems odd, notice that line where we declared hit point, it was declared as a vector 3. So always trying to give these commands vector 3 values. So here, new vector 3 laser.transform dot local scale dot x. Nope, spelled laser wrong. There we go. So that will be the first value in the vector 3. The second value is going to be laser.transform.localscale.y. And finally, hit.distance. So the first 2 basically are going to represent the thickness of the laser, and then the hit distance is going to be the Z. If you remember how the Z. You remember how we adjusted the Z was to then set it to 0, so that when we do cast it, and we can adjust its size without having to worry about it being a different size. Yeah, it's not too important, but it helps you understand. So laser.transform.localscale, boom, boom, boom. What that ends up doing is we know the distance between the controller and the hit point. So when we say we set the scale of this object to the hit distance, boom, it scales it up, and perfect. Now we have a visual representation of our raycast. Alright, so that is our show laser function. Any questions so far?
No. I mean, I like your graphic, that helped.
Awesome. Came up with that not too long ago.
Cool.
So in our update function is where we're now going to start calling that show laser function. First thing we need to do is determine input from the user. When are we actually going to go through this process of calling a raycast? So what we'll do is we will go if, I like to define the scope of my if statement. Now before we move on, I think it'll be easier if we just do the else first. So if and then else. You don't even need these. Generally speaking, how an if-else statement is to work is, we have the basic if statement. It has a condition. If those conditions are met, it will do whatever's inside the curly brackets. Now, if this condition isn't met, generally when we don't have the else statement, it just moves on, goes to do the other thing. But if we do have an else statement, then it will automatically do whatever's inside the curly brackets of the else statement. Now, a quick notch up from that is if you want, you can even go else if and add another layer of conditions. But basically the way we're doing this script is if you're pressing down the touchpad or the A button on your Oculus controller, etc., then we're going to do the whole show laser, call the teleport function, all that good stuff. But if we're not pushing it down, we're going to turn our laser off. So in our else statement, we want to do set laser dot set active false. That's us handling our if else statement ahead of time.
Okay.
Now, in our if statement, we're going to check to see the inputs. So if you're using the Vive, I'm going to go controller dot get press, and going to use a button mask. SteamVR for controller dot button mask dot touchpad. Boom. So this is going to return true as long as the person using the Vive controller is holding down the touchpad. Great, it's good for Vive users. What's our replacement for the Oculus? In that case, we do if go OVR input dot get. In the get function, we'll use OVR input dot button and then dot 1, 2, 3, 4. One of those two. One of those. So button 1 is going to be A, button 2 is going to be B, 3 is X, 4 is Y. So if I did button 1, starts with a capital letter, that is going to be the A button. Now, just remember that this is whatever you're comfortable. If you want to use a different button, feel free. Just make sure that you're attaching the script to the appropriate controller. If you're going to use button A or B, if that's on your right or on your left controller, where is that one? It is on your right controller. So button A and B are on your right Oculus controller, so make sure to attach the teleport script onto your right Oculus controller. So that's the alternative for Oculus, and if you're going to use a simulated hand, we'll just type if input dot get key. We'll type, just go with mouse 1.
What about, would it be too much to do like a mobile device, like a trigger or a touchpad or something, or would that be a whole different beast?
Right, so when it comes to, what are those called? The mobile device, so like a phone, if you touch the screen of a phone, it actually is the same as doing mouse 0.
Okay.
Right.
What about like a Samsung Gear or, Oculus Go, those type of trigger mechanisms or whatever?
Sure thing, I'll just pull up the developer items for that. So say Gear VR, input, Unity, and we're looking at, I think it's actually the same thing as Oculus. For button A and B, I think. No, let me check. Where is my Gear VR? Gear VR. Right, let me, so just give me a moment here.
Mm-hmm.
Yeah, so I believe it's actually the same for Gear VR.
Okay. Easy.
So VR input.get button 1. Huh. Okay. Alright, so on Oculus or Gear VR. Alright. Now on the Daydream, it is definitely a bit different. Let's see. Daydream Unity input. Pulling up their docs right now. You have made projects for them before? I can pull it up right away. You have a Daydream, right, Chad?
Yeah, but I'm not trying to. I haven't tried anything with it. I'm kind of focusing on the Go and the Rift.
Ah, nice. I think the Go is going to be very similar in terms of input, because it's also Oculus.
Yeah.
Now, while that loads, generally speaking, these are just different ways to do the input. This is a Daydream project where we have this little thing representing our controller. So when you're holding it out in front of you in VR, boom, this thing is there.
Mm-hmm.
And it looks like for the button you're looking for the button, it is gvrcontroller.app button.
Okay.
App button is going to be a particular button, but GVR controller. So if you're using Google Daydream, you would go if GVR controller dot lowercase vr. Yeah, so GVR controller dot, and then it would give you a list of options. And one of them would be the app button. I think you just type app button, and here you can do app button up as well, or app button down, or just app button. And that's the idea here. So you want to you want to get. You don't want get down here, because this function is going to be running as long as you are holding down the button itself. Input.getKey mouse 0 would be just touching the screen on your phone. So valid for Google Cardboard really. But for simulated hand, we're going to do mouse 1, and that'll be our right click. Alright, now with that said, let's take a look at what's happening on the inside. So number 1, we need to create that variable raycast hit. That's going to be the one storing all that information. Go raycast hit. Just going to call it hit, the variable. So now, since this raycast, this variable was declared inside the scope here, it's not going to be accessible from other functions. So we had to make sure to pass this as an argument when we call the show laser function, which over here is waiting, it's just waiting for it. Okay, so now with the raycast hit, after that variable is created, we're going to use the physics.raycast function. So physics.raycast, what that look like is physics.raycast, and now what is the raycast looking for? It's looking for an origin, a direction, and place to store that information in, as well as the max distance. So we can go transform dot position, and we can say transform dot forward, comma out hit. So out is going to be the spot in which we store this information. And lastly, it's just going to be our layer mask. We can just put to 1000. Now, once you've created this raycast, you're going to want to be able to use that information to then call the show laser function, as well as assign hit point a value somewhere. So now to do that, we will then say, hit point is equal to hit dot point. And then we will say show laser. Now, we might come across a problem here. If the raycast is unsuccessful, then trying to assign a value from this variable that does not have any information might cause us another problem, might not even work. So we try to encapsulate this physics raycast. So circle bracket in front and after, put that inside of an if statement, so that we only do these two commands if a physics raycast was actually successful. So let's put a curly bracket there, another curly bracket at the end of these two functions, and we're just going to indent them to make it look a bit nicer. Alright. So at this point, you should be able to, I'll save this, but at this point you should be able to just point your controller around and see a laser appear. Have that represent your raycast. Now let's finish up the script before we get into testing, just in the interest of time. The next thing we'll do is actually now implement our teleport function. So what this if statement has done is, if you're holding down the button that you're going to be using for teleporting, while you're holding it down, we're creating a raycast hit variable that is then going to have the raycast information stored in it. Raycast is going to be originating from your controller and pointing in the forward direction. So like a laser pointer, it's then going to, whenever it's successful, so if it does make contact with something on the end, it will then pass the location of where it hit to this variable called hit point. It will then also show a laser. And to do that, we're passing in that argument called hit, which is a raycast hit variable. So with that information, our show laser function can go through and find things like the hit distance. Alright, with that said, let's bring in a teleport function. Now we're not going to call it teleport just because the name of the script is teleport. We're just going to use a short form and say tele. Now this is basically going to be used whenever you release the button. So if you let go of the A button, you let go of the touchpad, you release the right mouse button, that is when you'll actually call the teleport function. So what does that look like? That's an if statement outside of the else. So after that, typing in if, define its scope, and as the condition, you'll write controller dot get press up. So this is for Vive. Controller dot get press up, and in here, the circle brackets will write Steam VR controller dot button mask dot touchpad. So now if this is let go, we'll call the teleport function. Only thing we want to make sure of is that we're actually, able to teleport first. If we're pointing up into the sky and then we call the teleport function, we're going to have a problem. So what do we need to do? We need to create a boolean that's going to track whether or not we can teleport. Let's go up at the top. We're going to declare a prefab, or we're going to declare a variable. This one is going to be a boolean, so public bool. We can call this one can we teleport, or I will just type should teleport. At the very top, declared a variable called should teleport, and it is a public boolean. Alright. So now back into our update loop. Now instead of just using the Vive touchpad, we're going to implement some of our other controllers. So when it comes to something like Oculus, we would then say if OVR input dot get up OVR input dot button dot 1. So this line is saying if you release the A button, we will then call the teleport function. Now, as I mentioned, we just declared this boolean should teleport. The idea behind that is now that you have these inputs, we're going to add a second condition. So we're going to go and should teleport. So and should teleport equals true, but if you just write the name out like that, it's checking whether or not it is true or false as well. If you do exclamation mark before, it's saying if it's not true, and if there isn't one, it says if it is true. Same thing with Oculus. You're going to have to do that should teleport variable as well. And for the simulated hand, we're just going to write if input dot get key up, and just going to type in the right mouse button, which is represented by mouse space 1. So if you release the right mouse button, boom, you're going to teleport as well. So we prep this. Oh, also make sure that should teleport is there as well. So I'm just going to comment out these lines, let you pick the one you want or write them all down so that you have a point of reference.
So mouse 0 is left click, mouse 1 is right click.
Exactly.
Is that right? Or?
That's right. That's right.
Okay.
All right. Now outside of the update loop, we're going to create our tele function. So let's make sure we're outside the scope. So I'm going to select one of these curly brackets and see where the end of the scope is. So here, that's the last curly bracket. I'm going to write my new function outside of it. So I'm going to create a void function. I'm going to call it tele. The first thing we want it to do is say should teleport is equal to false. So now it says that because, well, you successfully teleported. Now we're going to set it to false. You don't want to teleport right away again. And now we can call that function now that we have it defined. Going back into our update loop, we can call the tele function. So what we've done, we have an if statement that says, you know, if you release the right mouse button and should teleport is true, teleport. Just call the tele function. And what we're doing here is tele function, we're checking to see, or we're not checking anything anymore, we're just saying should teleport is now false, that we've successfully teleported. And what's the next thing we have to do? We actually need to move our character. One last thing before I forget. If the raycast is successful and we're showing the laser, that is the moment at which we want to show, or we want to say that should teleport is true. So right after that, you just put that in here, should teleport equal to true. That's one more line you add. Okay. Chad, are you caught up for now?
Yep.
Okay. So the very last thing we need to do is actually move our player to the location known as hit point. So how do we do that? We need a reference to our camera rig. So let me close this one, not quite what I wanted. There we go. So if you remember in VR, whether you're using Oculus integration with its camera rig or Vive, or what have you, this is the whole thing we want to move. So this camera rig, the Oculus camera rig, that's what you want to move. So we're going to take this whole thing and move it. So let's create a public variable to reference that. Let's go public. This is going to be, we actually just need the transform. We're not going to move anything else. Public transform. We'll call this one the camera rig transform. Right, so once you have that variable declared, it's public so you can link it. You're going to go down to our should teleport function and just say boom camera rig transform dot position is equal to hit point. Boom, that's it. determined our teleport. We're pointing with our raycast. We're saying, okay, there, we've represented our raycast visually with a laser. When we release the button that we've been using, teleport is called, and it changes our camera rig's position.
So will that just move kind of the camera position, but all your avatars and your hands and everything else will stay back away from that?
No, it should move everything.
Okay.
It's just a matter of what you're linking there.
Okay. All right.
May need to do a little bit extra with you, Chad. We might need to make some parenting relationships, but we'll see.
Okay.
Thing I don't want to miss out on here. Should teleport is true. Do that. Point up. I think it's a good idea to then set should teleport to false at some point here. Just trying to remember that there's some sort of logic error that's happening right now. So I think it might be worthwhile to avoid some logic error that after you declared a raycast to be successful and then your setting should teleport to true, might good for safety if we create an else statement right underneath that then sets should teleport to false. If we're not successfully showing a laser, we should teleport to being true. And I think to make it look even neater, you can add that set laser to false in here as well. Alright, Chad, are you up to speed here?
Almost.
Remember, watch out for those scoping errors.
Mm-hmm. Should teleport it. I'm good.
Good? Alright, so let's save this. Let's go back into Unity. What you'll do is, based on what controller you chose, if it's button A, I believe it's your right hand, right? Yeah. So you want your controller right?
Yeah.
So you're then going to then just take your new teleport script, so teleport, boom, and notice all these variables that are showing. You only really need to see camera rig transform and laser prefab. You don't need to see all these other variables. So we go back to our script. Let's make some of them private. Make it a little bit cleaner. So hit point, you don't need to see that, so let's make that private. Laser, don't need to see that, let's make that one private. Laser prefab, yes, we need to link that in the inspector, so we do need to see that. Should teleport, don't need to see that, so we're going to make that one private. Camera rig transform, yes, you need to see that because you need to link it. So let's save that, go back to Unity. Hit point, laser, should teleport, should be private. Laser prefab and camera rig transform should be public. You understand the reasoning behind that, Chad?
Just to clean it up, or is there more to it?
To clean it up, basically you don't want those to be visible out there.
Got it.
Alright, so now let's get back into Unity, and you'll see that with this updated, boom, after a second or so, there we go, nice and neat, right? So now what we're going to do is, let's go into our prefabs folder, where we kept our laser. Let's give our camera rig, or let's click and drag our laser prefab into that laser prefab variable slot. It says camera rig transform. That's where we're going to take our whole camera rig, click and drag it into that slot there. Cool.
So you already dragged the teleport scripts onto the controller. I haven't done that yet.
Yes, that's right.
And I would put it on my right hand because it's the Oculus, correct?
Put it on your right hand, because it's the Oculus.
Right
That's
hand
correct.
controller,
Yes.
right controller here.
Yes, exactly.
Okay, teleport and just drag it on top of the controller, right?
Now, if you're using the simulated hand, where is it? So now if you're using the simulated hand and you decide to attach the script there, want to make sure that instead of camera rig transform, you're actually just passing over the hand itself. And then laser prefab, that's the same. You're going to want to put that there. I'm just going to quickly look through. Right now it's set up to work with the mouse, it appears.
I gotta compile error. I have to look at it. A script. It's not letting me do that. It's not letting me drag the script on top. Must have an error somewhere. Can you pull up your script when you get a chance?
Yep, sure, one thing, let me just, oh, got some error of myself, it's being slow. Oh, my mistake, it shouldn't be mouse with a capital M, you want mouse with a lowercase m. For mouse 1 and mouse 1 over here. There we go.
Okay.
That as well, let me just make a few adjustments. There we go. You see that holding down the right mouse button, I can see this laser. And when I release, boom, I get teleported.
Cool. Swimming hand. Oh.
Alright. Alright, Chad, I'll put the script back up. What are you looking for exactly?
Like around, well, my line's like 40 or so. The physics, if physics raycast, the raycast hit, there we go. Show laser hit. Show laser. Oh, okay. I just put a space. I don't know if that's going to save it. Let me try again. Nope. So it's saying I should fix some issues, but I don't see any red
Okay.
errors.
Let me see your screen here.
Okay. So when I take, when I take my this and I try to drag it over, I get this.
Compile errors. Okay. Yeah, let's take a look at your console here. You go ahead and okay, and then let's take a look at the console. Can you click on collapse at the top left of the console? Unexpected symbol, unexpected symbol, unexpected symbol. Okay, those are the ones we want to tackle right away. Let's double click on the first one.
Not the shader stuff, just the unexpected symbols.
Yes, that's the one. So it looks like you're missing a circle bracket after the if statement on line 33. The end of line 33, before the comments, you need one more circle bracket. Not put it there.
Not here.
No,
but
not that one. You want the circle bracket, just like you have around the OVR
okay.
input. Dot get
1,
OVR.
2. So here.
Yes, exactly.
Huh? That's something else. Show laser.
Can you scroll up to your show laser function? Okay. Let's find that third error that they were talking about. I'm not sure what's wrong with the show laser quite yet. Is that it? Oh, I see. You're missing a semicolon after line 42.
Okay. Nice if that would have been red or something, but okay.
Yeah, it showed the part after it being red. So whenever you see red, make sure that you're looking before and after.
Okay.
Okay. So yeah, I think that should be it. I remember there being 3 errors, but I don't recollect what the third one was. But hit clear. Let's see what's still around. Just hit clear. Okay, cool. Now hopefully you can click and drag that script onto it, no problem.
Yeah. Okay.
So now with your camera rig, I think you want your OVR camera rig as the child. Sorry, as the reference. So select your controller left game object in the hierarchy tab, and then click and drag OVR camera rig into the camera rig transform slot. Perfect. And if you remember where you created that laser prefab, you want to click and drag that prefab into the laser prefab slot there. Boom, just like that. So, yeah, I think you can give it a go. Hopefully that doesn't give you any problems.
Oh shoot! I'm jammed up. I forgot I have not started. I gotta unplug all this stuff. So the A button should do something. Oh, cool.
I'm not able to see
Uh-oh.
anything.
I had a laser. It made him disappear.
I'm not able to
But...
see anything though.
Oh, you're not? Oh, okay.
I just see
Let me,
a still screen.
okay, let me stop this. Let me reshare.
Okay. If you remember on the laser prefab, we don't want a box collider on it. You just want to double check that.
Okay. Laser prefab.
The other one.
We don't want box collider.
Okay, that looks good.
It's fine.
And that's the one you're referencing, right?
Yeah.
Cool, cool.
Can you see now?
Yes, now I can see you.
All right, so A, there's my laser, which is cool. And
All right, and you teleported.
It teleported.
Boom.
Cool. Awesome. Oh, come back here, monster. There we go. Oh, tip over. All right, cool. All right,
Awesome.
thank you. That's awesome.
All right, right on, Chad. Now, do you think you could explain to me how the sequence of showing the laser works?
No, maybe after I watch your video a few times. I love the fact that I'm gonna be able to watch your video and look at the paint explanation. Yeah, it's complicated, like you said, but
that was a good explanation, as you said, right?
it is without the visuals really help because it is quite intense. But it's amazing. That's kind of where I'm glad we're there now. I mean, now the fact that we can not only grab things, shoot things, move around, but we can move around in a completely different form factor with the mobile headsets.
Yes.
That's huge. So that's awesome.
All right, awesome, Chad. Your attitude was great, uplifting for me today.
Well, I mean, how can it not be? I'm very happy.
All right, you have a good one. I'll see you on Monday. Is that right? Today's Wednesday.
It's Wednesday, yep, Monday. Looking forward to it. Get some rest. Hope you feel better.
Thank you. Take care.
Take care. Bye.